Hello everyone, good evening to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. I think mic is on. So am I audible? So hello everyone, good evening to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. I hope I am audible. Yes, Dr. Yuvraj. Anything?
Sir, audible, sir.
Okay. So actually the problem is I am facing some problem with my OBS screen recording.
Hello.
Hello. Am I audible?
Hello, your voice is not clear, sir.
Wait. Am I audible now?
Now it's audible.
Okay, I'm saying that I'm facing some problem with my OBS screen recording. Some technical fault is there. So even if I take this class, I won't be able to upload this class on YouTube.
Okay.
Yeah, that is why I'm trying to fix this problem. Let us say. So if I take so if I take this live session tomorrow at the same time, is it possible? I will try to fix this issue.
Oh, okay, sir. I'll join tomorrow.
Yeah. Please join at the same time 6. Okay.
Okay. Thank you.
Okay. Thank you. So, hello everyone. Good evening to all. My name is Abhishek Pandey. I am a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. Today we are going to discuss about week 7 assignment. So let us start. So question number one is regarding the potential function of a vector field. Okay. So we need to find the potential vector function of a vector field. So vector field equation is given by this: 2xz minus y cube z square I cap plus minus 3xy square z square plus 2 j cap plus x square minus 2xy cube z k cap, okay, is equal to, so we need to find the potential function. Let us look at the solution. Okay, so let phi be the potential function. Potential function of vector field f. So of vector field f, that is f is basically equals to gradient of 5. Okay, which is, that is f is nothing but del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Okay, which means del phi by del x is equals to 2xz minus y cube z square. Now this gives you that phi is equals to x square z minus xy cube z square plus some function phi 1 of y comma z. Okay. Now we already know that now, so del phi by del x is this, del phi by del y is equals to minus 3xy square z square plus 2, and del phi by del z is equals to x square minus 2xy cube z. Okay, so now partially differentiate with respect to y. This you will get as 3xy square z square plus del phi 1 by del y. This implies that del phi 1 by del y is nothing but 2. Okay, so this give you that phi 1 is equals to 2y plus some function phi 2 of z. Okay, so therefore phi is equals to now x square z minus xy cube z square plus 2y plus phi 2z. Okay, now del phi by del z is equals to x square minus 2xy cube z plus del phi 2 by del z. This implies del phi 2 by del z is basically equals to 0. That is phi 2 of z is basically some constant c. Okay, so therefore phi is nothing but x square z minus xy cube z square plus 2y plus c. So this is your potential function. I hope it is clear to everyone. Okay, let us look at the next problem. Question number 2. So the question number 2 is, if r is equals to xi cap plus yj cap plus z k cap, and this r is basically the modulus r, then find the value of find this divergence. So let us look at the solution. So before going to at the solution, let us recall that this del r to the power n is nothing but n r to the power n minus 2 r vector. Okay, so we will use this. Okay, so therefore r to the power minus 3 is nothing but minus 3 r to the power minus 5, this thing. Okay, so divergence of r 1 by r cube, this is equals to now divergence of minus 3 r to the power minus 4 r vector. Okay, so now as we know that r is equals to under root x square plus y square plus z square implies r to the power 4 is x square plus y square plus z square to the power square. Okay, now divergence of any vector v is nothing but dot product. Okay, so this thing will be for divergence of minus 3 r to the power minus 4 r vector is nothing but, write it here, del by del x I cap plus del by del y j cap plus del by del z k cap with dot product minus 3x upon x square plus y square plus z square whole square I cap plus minus 3y upon x square plus y square plus z square whole square j cap plus minus 3z upon x square plus y square plus z square square k cap. Okay, so this you will get basically, so minus 3 will be common, you can see that one, del by del x of x by x square plus y square plus z square whole square plus del by del y of x square plus y square plus z square whole square plus del by del z of z upon x square plus y square plus z square whole square. Okay, now this will be minus 3 and here you will get x square plus y square plus z square whole square minus 4x square into x square plus y square plus z square plus x square plus y square plus z square whole square minus 4y square x square plus y square plus z square. Again x square plus y square plus z square minus 4z square x square four z square x square plus y square plus z square. Okay, upon x square plus y square plus z square to the power whole 4. Okay. Now this thing is nothing but you take x square plus y square plus z square common. So here you will get x square plus y square plus z square minus 4x square minus 4y square minus 4z square. Okay, this will be 3 3 3. Okay, upon x square plus y square plus z square whole 4. Now this thing is nothing but minus 3 and this minus, so this will be minus x square plus y square plus z square into x square plus y square plus z square upon x square plus y square plus z square whole to the power 4. So this is nothing but 3 upon x square plus y square plus z square whole square. Okay, so this is nothing but 3 r to the power 4 or 3 r to the power minus 4. So this is your answer. Let us look at the next problem, question number 3. So question number 3 is about, let v is equals to x square minus y square I cap plus y square minus z square j cap plus z square minus x square k cap. Okay, be a vector field, be a vector field, the value of this thing. At the point 1 comma 2 comma minus 1 is, so we need to find this one, this value. Now the solution is, okay, so given that okay, now this thing, first we'll calculate this thing. So this is nothing but del 2 by del x square plus del 2 by del y square plus del 2 by del z square. Okay, now this is nothing but, if you calculate, this is nothing but 2i minus 2k cap minus 2i plus 2j cap plus 2k cap minus 2j cap. Okay, this is 0. Okay, now we need to calculate this thing dot v. So this is nothing but del by del x of x square minus y square plus del by del y of y square minus z square plus del by del z of z square minus x square. Okay, so this is nothing but okay, so this is nothing but 2x plus 2y plus 2z. So this is now del by del x of 2x plus 2y plus 2z I cap plus del by del y of 2x plus 2y plus 2z k cap, sorry, j cap plus del by del z of 2x plus 2y plus 2z k cap. And this is nothing but 2 I cap plus 2 j cap plus 2. So this is your answer. Let us look at the question 4. So let P is equals to y I cap plus xz j cap plus yz k cap, and Q is equals to x square I cap plus 3y square j cap plus z k cap be two vector fields. So these two are vector fields. Then del dot P cross Q is equal to this. We need to find out. Let us look at the solution. So first recall that this thing we can write it as Q. This thing we can write it as dot Q minus dot P okay. So now if you calculate this thing, so first let us calculate del cross P. So this is nothing but ijk and del by del x, del by del y, del by del z, y, xz, yz. So this is nothing but I into z minus x plus z minus 1 into k cap. Okay. Also let us calculate this thing. So this is I cap, j cap, k cap, del by del x, del by del y, del by del z, and x square, 3y square, and z. So this we will get as minus 0 j cap plus 0 k cap. This is 0. Okay. So the only thing we need to calculate is cross P dot Q, and this we will get it as I and k. So x square into z minus x plus z into z minus 1. So this will give us minus x cube plus zx square plus z square minus z. So this is your answer. Is it clear to everyone? So now we'll move towards the next question. Question number 5. So question number 5 is if f is equals to y square I cap so if f is equals to y square I cap plus z square j cap plus x square k cap, and this h is equals to basically yz I cap plus 2k cap, then we need to find the value of curl of f cross h. Okay. Solution. So recall that this curl of f cross h, this is equals to h dot this minus h cap divergence of f plus f into divergence of h minus f dot h. So we'll use this formula. Okay. So if you see, divergence of f is nothing but delta dot f cap. Okay, so this is nothing but, if you see, del by del x of y square plus del by del y of z square plus del by del z of x square, this is 0. Okay, and so next thing is, so once you do this one, so this will become yz of del by del x plus j0 to del by del z, okay, of f. So this will give you yz del by del x of f plus 2 del by del z of f, okay, and this is del by del x of f is 2x k cap. So 2xyz k cap plus del by del z of f, if you see this one, del by del z of f, so this is 2z j cap, okay. So already 2 is there, the 4z j cap, okay. This thing is clear. So this part is ultimately 0. This part we have calculated. Okay. So now the next thing is we have to calculate divergence of f, divergence of h. So this is this thing, and divergence of h will give us del by del x of yz plus j cap is 0 del by del z of 2. So this is basically 0. So this quantity is also 0. This one is also 0. And now we have to calculate f dot this one. Okay. So f is your f is y square del by del x plus z square del by del y plus x square del by del z, and this thing, okay, fine. Now we need to calculate this thing. So f dot del of h, this will be y square del by del x hk x vector z square by del y h plus x square del by del z h. Okay. Now you see h del by del x of h. So del by del x of h is 0. Del by del y of h. So it will be z I cap. So this will be 0 plus z square into del by del y of z. So z. So z cube z cube I cap plus x square del by del z. So this will be y I cap. So x square y I cap. So this is nothing but z cube plus x square y I cap. Okay. Now the given value is, so curl of f cross h is nothing but okay, so 2xyz k cap 2xyz k cap plus 4z cap plus z cube plus x square by I cap. So this is your answer. Let me look at the next question. So after this, I will mention some important facts about line integral and its application, and then we will move towards the next assignment. So line integral and its applications. So write the formulas. So basically, so let this C be a simple smooth curve, okay, and R is equals to basically xt I cap plus yt j cap plus zt k cap be its be a parametric representation of C, okay, where t is running from A to B, okay. Let this fxy comma z be a scalar function continuous on C. Then we define the line integral of f over C with respect to arc length denoted by f of x, y, z. This is the arc length element. This is nothing but t equals to A to B, f of xt, comma yt, zt, and root over, this is basically dx by dt whole square plus dy by dt whole square plus dz by dt whole square dt. Okay, I hope this is clear. Similarly, if your f is instead of scalar function, if it is a vector valued, then also it is quite easy to do that one. Okay, so if v is vector valued, okay, I mean v is v1 of x comma y comma z I cap plus v2 of x comma y comma z j cap plus v3 of x comma y comma z k cap. Okay, then in this case the integral is defined as like this. Okay, now let us look at one question based upon this concept. So this is question number 6. Okay, so let C be the path along the curve this x square minus 4x plus 4 from 0 comma 4 to 2 comma 0, then this integral, we need to find this integral. So y I cap minus 3x j cap dot dr is this, we need to find it out. So so if you see, y is nothing but x minus 2 whole square. Okay, so parametric representation is easy. Parametric representation of C is basically xt comma yt is nothing but okay, so 2 plus t, so let xt is equals to 2 plus t and yt is equals to xt square, where t runs from minus 2 to 0. Okay, Now this integral over c, so this will minus 2 to 0, and this dr, so y dx minus 3x dy. Okay, so dx is equals to dt, and dy is equals to 2 t dt. Okay, so 2 xt into dy dt. Basically yt is nothing but, so 2 plus t whole square, so y of t, so dy is equals to 2 into 2 plus t dt. Okay, so 4 plus 2t, so dy equals to 4 plus 2t. Just let me check once again. This is nothing but, so, okay, oh sorry, I have written something wrongly here. This yt is nothing but t square, because xt is this, so once you put 2 minus 2 t square it is, where t is running from minus 2 to 0. Okay, so dx is equals to dt, and dy equals to 2t dt. Okay, so y is equals to t square, dx is equals to dt, minus 3 into 2 plus t into 2t dt minus 2 to 0, and this is equals to t square minus 12t minus 6t square, so minus 2 to 0 dt, and this is equals to minus comma 5t square plus 12t integral minus 2 to 0 dt, and this is nothing but minus of 5 by 3 t cube plus 12 by 2 t square minus 2 to 0. So this is nothing but minus 0 minus, so minus 40 by 3 plus 24. Okay, so now this is minus, and so minus minus plus, this will be now 72 minus 40 by 3. So this is nothing but 5 by 3 t cube plus 6t square. So this is 43 plus 50 by 3. So this is nothing but 32 by 3. This is the answer. I hope this is clear. Now the next part is, using line integral we can get the work done by force. Okay, so this is nothing but applications. Let us see some applications. So this is work done by a force F in displacing the particle from the point P to the point Q along the curve C is basically point P to Q F dot dr. Okay. Now the next thing is work done by a conservative force. Work done by a conservative force. Okay. So basically, what do we mean by conservative force? So F is conservative means conservative vector field means vector field. This F means that is F can be written as grad of phi, where phi is a scalar potential, is called scalar potential. Okay. Okay. So now, if so, our idea means our result is work done by a conservative force does not depend upon the path between 2 points. Like here we have said that work done by a force F displacing the particle from the point P to Q along this curve C. So if this force F is conservative, means this is independent of path. Work done is independent of path. Okay, this is this thing we are going to show. So means you go along any path from P to Q, your work done will be the same. Okay, so this is our result. So let us see. So basically, W is equals to F dot dr. Okay, let us say some C star from P to Q, some curve is there. So this is nothing but gradient of phi dot dr, and this is nothing but del phi by del x dx plus del phi by del y dy plus del phi by del z dz. This is C star, and this is nothing but from the point P to Q, this is d phi, and this is nothing but phi of x, y, z of P to Q. So as you can see that it does not depend upon the path, it depends only upon the 2 points. Now, one more thing from this you can conclude that work done from if it is path is closed path, okay, so work done will be 0 by a conservative force. Okay, so this is basically phi of q minus phi of p. So let me mention some important facts, then we will move towards the problem. So important facts. Important facts. So the first thing is not the first thing, then something I will write. The main thing which I'm going to use, that thing I will write. So if f is equals to f1 I cap plus f2 j cap plus f3 k cap be a vector field on an open and simply counted region, open and simply connected. Region, if f1, f2, comma f3 have continuous first order partial derivatives in D, and this thing holds del f1 by del y, del f2 by del x, del f1 by del z, del f3 by del x, del f2 by del z, del f3 by del y. Then the vector field f is conservative. So then the vector field f is conservative. So let us look at some problems now. So this will be, I think, question number 7. Okay. So the work done by the force, this F cap is minus xy I cap plus y square j cap plus z k cap in moving a particle over a circular path x square plus y square equals to 9, z equals to 0 from the point P300 to 030 is. So we need to calculate the work done, and we know how to calculate the work done. Solution is work done W is equals to C F dot D. Okay. Now the parametric representation of C is x of t is equals to 3 cos t, y equals to 3 sin t, and z of t equals to 0. Okay. Where t runs from 0 to pi by 2. So dx is equals to minus 3 sin t dt, dy is equals to 3 cos t dt, and dz is obviously 0. Okay. So w is nothing but this is f dot dr. So this will be integral f dot minus xy dx over c plus y square dy plus z dz, and this will be x is equals to, so this is 0 to pi by 2 minus 9 sin t cos t into minus 3 sin t dt plus 9 sin square t into 3 cos t dt. So this is nothing but 0 to pi by 2, and this is 27 sin square t cos t plus 27 sin square t cos t dt. So this is 54, 0 to pi by 2 sin square t cos t dt. And this is easy to calculate. This will be, let us take sin t is equals to u, so this is cos t dt is equals to du, so this will be u cube, so 54, and this will be from 0 to 1 u square du. This is 54 by 3. This is, okay. So this is the solution. Now let us look at the question number 8. So the value of the line integral this p is from 0 0 0, q is from 832 2x y square minus 2x z square dx plus 2x square y dy minus 2x square z dz. So the idea is solution. So the idea is what we will do is, so here we will see for the potential for which phi is equals to f is equals to grade of this one. Okay. So let us see del phi by del x is equals to 2x y square minus 2x z square. So phi is basically equals to x square y square minus x square z square plus phi 1 of y comma z. Okay, and so del phi by del y is equals to 2x square y, and del phi by del z is equals to minus 2x square z. Okay, now del phi by del y is nothing but 2x square y plus del phi 1 by del y of y comma z. So this implies del phi 1 of del y of y comma z is some function of z only. Okay, so now phi is equals to x square y square minus x square z square plus phi 1 of y comma z. Sorry, this should be 0. This should be 0. So this implies phi 1 is basically equals to some phi 2 of z. So this will be phi 2 of z. Now del phi by del z is equals to minus 2x square z plus del phi 2 by del z, which implies del phi 2 by del z is equals to 0 and implies phi 2 is equals to c for some constant c. Okay. So phi is equals to x square y square minus x square z square plus c. Okay, phi is this. Okay. So this implies the integral, let us say this integral is I. So this integral is nothing but I is equals to integral 0 0 0 to 832, which is d phi, and this is equals to phi of x comma y comma z 0 0 0 to 832. Okay, so which is nothing but 64 into 9 minus 64 into 4. So this is 64 into 5. This is basically 320. So this is the value of the integral. Let us look at the last question, which is based on the same concept. So let f is equals to y plus sine z I cap plus x j cap plus x cos z k cap, and C is the straight line segment from P 0 to 2 pi to q 1 comma 4 comma pi by 2, then I is equals to integrals over C f dot dh. So we will show that this vector field is basically conservative. So basically the curve C doesn't matter here. Okay. So how we will show this one? Recall this one, this thing. So we'll use this thing. And this thing is clearly satisfied here. Okay. So therefore, this one is clearly satisfied. So clearly, okay, sorry. So clearly, F is a conservative vector field, that is, so F is equals to grad phi. So in this case, this integral I is nothing but phi of x comma y comma z to these 2 points, 0 comma 2 comma pi to 1 comma 4 comma pi by 2. Okay. So let us see what is phi. So since f is equals to grad phi, so del phi by del x is equals to y plus sine z, and del phi by del y is basically equals to x, and del phi by del z is basically equals to x cos z. Okay. So phi is basically equals to yx plus x sine z plus some function of y comma z. Now del phi by del y is equals to x plus del phi 1 upon del y. This implies del phi 1 by del y is some function phi 2 of z only. Okay. So this implies phi is equals to yx plus x sine z plus phi 2 of z. So in this case, this implies del phi by del z is basically equals to x cos z plus del phi 2 by del z, and this, while comparing with this one, we will get phi 2 is equals to some constant c. So this implies phi is equals to yx plus x sine z plus c. So integral I is equals to, first we need to put the point 1, 4 pi by 2. So x equals to 1, y equals to 4 plus sine pi by 2 plus c minus, we need to put 0, 2 and pi. X is 0, so this is c only. So this is c only. So this we will get as 4 plus 1. So 4 plus 1. This is equals to 5. So I is equals to 5. This is your answer. So hence we are done with the week 7 assignment. I hope this is clear to you. So we'll meet in the next class, probably the last class for the week 8 assignment. So thank you everyone. So I'm closing the meeting.